So in today's class we're going to see the previous questions and practice problem, okay, of the nucleophilic substitution reaction. Okay. So the first question, write down the first question. Which of the following on hydrolysis gives racemic alcohol? Okay. So question number one, it is about the racemic alcohol. Okay. So the racemic product will be formed in what type of reaction? It will be in SN1. Okay. So you need to identify which of these will be going to form the SN1 product. Okay. So option A is this one, and option B C. So you can give your answer. Okay. So this will be completely interactive. సో మీకు ఒకవేళ ఆన్సర్ వస్తే చెప్పండి, దాన్ని బట్టి ఇంకా ఫర్దర్గా ఎక్స్ప్లెయిన్ చేస్తాను. స్క్రీన్ వస్తుందా? అవునా? So I think now it is visible. Is it? Is the screen visible? Yeah. So now you need to identify which is going to give the SN1 product, and it should be chiral center, so that it is going to give the resonance mixture. Okay. So in SN1, if it is not a chiral center, it will not go. It will not give two different products. Okay. So which of the following is going to give racemic alcohol? So if it is A, it is a tertiary. It is a tertiary alkyl halide. Okay. But the thing is, it is not having the chiral center. Okay. So when four different groups are present on a carbon, then it is considered to be chiral center. Okay. So this is not a chiral center, so it will not give racemic mixture, but it is a tertiary alkyl halide, so it will follow the SN1 reaction pattern only. Okay. In the next, if it is a having four different groups, then it is a chiral center. Okay. So it can give the racemic mixture if it follows the SN1, but this is also not going to give the racemization product. Racemization is not going to happen because this is a primary alkyl halide, not a tertiary alkyl halide. So it will be going to give SN2 type of reaction, but not SN1. Okay. So this is having four different groups. Okay. And it is a tertiary alkyl halide, so it can undergo SN1 and it can give racemic mixture. Okay. So this is a probable starting material that will give racemic product. Okay. And this, if it is tertiary, it will undergo the racemic undergo SN1 mechanism, but due to lack of chirality, it will not give racemic mixture. Okay. So if you are not confident on this type of question, you need to see once again, or you need to review the last class, so that you will identify the mechanism types and what are the factors that are governing for the SN1 and that are governing for the SN2. Okay, so if you are able to know the factors, then it can be easily understandable. Okay, you can identify which mechanism and which product. Okay, so if I write the reaction for this, so in aqueous KOH or any base, okay, any nucleophilic substitution reaction, so this will be going to leave, okay, so before the attack of the KOH, because this is a tertiary alkyl halide which is going to give the stable carbocation. So as the carbocation is planar, there is a possibility of OH attack from the above and from below. Okay, so both the possibilities will be there. So it will be going to give two different products. If it is from the above, it will be like this. If it is from the below, it will be like this. The mirror images will be going to form. Okay. So this combination is called racemic mixture. Okay. So question number 2. So here is the starting material that is given. These all are previous questions that are asked in different examination. So once you are comfortable with this, you will be able to do the previous examination questions without any difficulty. Okay. So when I use sodium cyanide or potassium cyanide, okay. So what is the nucleophile in this? When you use sodium cyanide and potassium cyanide? Yeah, it is ionic, so it will be given Cn minus. Okay. So the nucleophile will be Cn minus. So it will be going to give cyanide attachment. So if I indicate plus and minus like this, so it is going to indicate a racemic mixture. Okay. So positive enantiomer and negative enantiomer both are going to form. Okay, because this is a tertiary. Okay, and this is going to follow SN1 mechanism, and this is a chiral center. Okay, so it's going to give racemic mixture. Okay, so my question is, if I or if in the reaction uh, KCN concentration is doubled. Okay, so in this reaction, if the KCN concentration is doubled, so what is the rate of the reaction? So option A, rate gets increased by 4 times. Option B, increased by 8 times. Option C, increased by 2 times. Option D, increased by 0 times, means no effect. What could be the answer? So it is undergoing SN1 mechanism. So the rate of the reaction depends on, is it 2 times Ravani? So in SN1, rate will depends on what? No effect, yeah. So in SN1, the rate is directly proportional to the starting material of alkyl halide but not the nucleophile. So this is a nucleophile. If I increase the concentration of nucleophile, there won't be any change because the rate determining step is leaving of the alkyl halide. Okay. So rate is only depends on the concentration of the alkyl halide in SN1. Okay. So these are the concept based questions which going to repeat in every time in every exam. So be focused on this. Okay. So next question number 3. In SN1 reaction, both alkyl halide concentration and nucleophile concentration. Okay. If double, if double. So the rate of the reaction is option A, same 4 times increase, option B, 8 times increase, option C, 2 times increase, option D, no anything. So, so it will be going to increase 2 times because when alkyl halide is only proportional to the rate. Okay. Alkyl halide concentration is only proportional. If the rate or if it is this increased 2 times, rate is also increased 2 times. Okay. So when it is nucleophile concentration is 0. Okay. So whatever may be the number of times is going to increase, so it will be 0 only. Okay. So rate will increase and rate will change according to the concentration of only alkyl halide as it is a SN1. So it's going to change only with the concentration of alkyl halide. That is also as proportional to the concentration of the alkyl halide. Okay. So ఇక్కడ 2 times పెంచితే ఇక్కడ 2 times, ఇక్కడ 4 times పెంచితే 4 times, 8 అయితే 8, ఇక్కడ half అయితే half. Okay. Next. R configuration containing tertiary alkyl halide on hydrolysis gives dash configuration alcohol. So option A, R configuration tertiary alcohol. Option B, S configuration tertiary alcohol. Option C, 50% R and 50% S configuration tertiary alcohol. D, none. So see, because it is a tertiary alcohol which needs to undergo from the SN1 mechanism. Okay. So when it is SN1 mechanism, so it's going to give racemic product. Okay. Racemic product. So when it is racemic product, there will be a 50% R and 50% S. Whatever may be the starting material, whether it could be R, whether it can be S. Okay. So initially I am taking the alkyl halide, that is R. If it is undergo with the SN1 with the hydrolysis or base hydrolysis, whatever may be. So it's going to give alcohol, that is with 50% R, 50% H. This is called racemic mixture. If it is a chiral, okay, chiral tertiary alcohol, okay, make a note of that. Right. So most reactive compound in SN1. Okay, you can write complete question. Which of the following is most reactive in SN1 reaction? Okay, so option A, methyl chloride. Option B, ethyl chloride. Option C, isopropyl chloride. Option D, tertiary butyl chloride. And option E, deuterated ethyl chloride. So which could be more reactive? So as it is SN1, so whether the primary alkyl halide is going to react or tertiary? Tertiary. So this is the only tertiary alkyl halide, okay, that's going to react fast. Okay. So because this is going to form a stable carbocation when it's going to leave the halogen. Okay. So that is the driving force for the reactivity of these compounds. Next. Similar question. Option A is B. So among these three, which will be more reactive? So SN1 reactivity is simply depends on the stability of carbocation. Stability of carbocation. So whichever is going to form a stable carbocation, that will be going to give more reactive. Okay. So if this leave, it's going to give cyclopropyl carbocation. If this is, it's going to give the secondary carbocation, which is stabilized by the two cyclopropyl rings. If this is there, it's going to give tertiary carbocation, which is going to support by the three cyclopropyl rings. Okay. Among the carbocations that are listed in your organic chemistry, this is the most stable carbocation. Okay. Most stable carbocation. Even stable from the then the benzyl and propylamide. Okay. So this is the most stable carbocation. So its reactivity will be the maximum. Okay. In SN1 reactions. So similar, next question. So it is also based on the reactivity. So SN1 reactivity. Option A, allyl bromide. Option B, diallyl bromide. C. Tri-adenyl bromide. Option D. Phenyl bromide. So among these, what is the order of the SN1 reactions? So it is directly proportional to the stability. Okay. So stability of the carbocation. If you know the stability order, then it will be easily solvable. So which is most stable carbocation among these? C. Because this is most conjugated among these three. So C will be the maximum. Okay. Then B, then A. Okay. Vinyl carbocation is least stable among all these. So reactivity will be like this. Okay. So if the same question asked for the SN2, okay, SN2, okay. So whichever is not readily going to give the carbocation will readily be going to give transition state, or will be whichever is not readily undergo SN1 reaction, which will readily undergo SN2 reaction. Okay. So